Assalamualaikum dan selamat sejahtera. Nama saya Nur Amirah Husna binti Muhammad Sufian.
Hi, so my name is Nurul Adila binti Bugim.
Hi, Assalamualaikum. My name is Nur Anisa binti Ismadi.
Hello guys, my name is Nur Azmina binti Ismail.
Let's get started with question number 1. Prove that the positive integer p choose 1 is equal to p. The formula we use for this question is n over k equal to n factorial divided by k factorial times n minus k factorial. From this question, we get n equal to p and k equal to 1. So p over 1 equal to p factorial divided by 1 factorial times p minus 1 factorial. So we get p over 1 equal to p factorial divided by p minus 1 factorial. The answer we get is p over 1 is equal to p.
For question number 2, by using binomial theorem, find 3x minus 4y to the power of 5. The expansion is given by the following formula. A plus b to the power of n equal to the sum from k equal to 0 to n of n choose k times a to the power of n minus k times b to the power of k, where n choose k is actually means equal to n factorial divided by k factorial times n minus k factorial. From these questions, a equal to 3x, b equal to negative 4y, and n equal to 5. Then we will start to apply this to our question. Therefore, 3x minus 4y to the power of 5 equal to the sum from k equal to 0 to 5 of 5 choose k times 3x to the power of 5 minus k times negative 4y to the power of k. Then we're gonna start at k equal to 0, k equal to 1, k equal to 2, k equal to 3, k equal to 4, and k equal to 5. So for the final answer, 3x minus 4y to the power of 5 equal to 243 x to the power of 5 minus 1620 x to the power of 4y plus 4320 x to the power of 3 y to the power of 2 minus 5760 x to the power of 2 y to the power of 3 plus 3840 xy to the power of 4 minus 1024 y to the power of 5.
The followings are about binomial theorem and Pascal's triangles. How Pascal's triangles relates to binomial theorem. By using Pascal's triangle, the coefficient of an expanded binomial form of a plus b power of n, which is the triangle's rule, could be found. The coefficients way can be used in order to complete the extended binomial according to the binomial theorem. For question B, give one example for your statement in A. Elaborate the answers. So, what is Pascal's triangle? Pascal's triangle is a triangular arrangement of numbers that gives the coefficients in the expansion of any binomial expression. So, for the calculation, we have to use the expanded binomial formula, which is a plus b to the power of n. N plus 1 is equal to 5, which is the fifth row. And the value of n is 4. By using the binomial theorem and Pascal's triangle, we can expand the expression. So, we can see that if a plus b to the power of 4 is being expanded by the coefficient way, the value of Pascal triangle from left to the right is 1, 4, 6, 4, and 1. Then, on the fifth row, which is n equal to 5 minus 1, the coefficient value is indeed similar as the expansion from binomial theorem. So, we can clearly see the expansion of binomial theorem, which is 1, 4, 6, 4, and 1 is from the left to right. Let A over B is for AB, which is the elements of integer. Prove that A over BC. Given that is A over B is AB is the elements of integers. Prove that A over BC. So, let A over B is equal to B equal to AK, and K is elements of integer. So, we can say that the definition of divisible is used. BC is equal to A to the power of K, which is K is the elements of integers. So, let M equal to K, and M is one of the elements of integers. The final answer is BC equal to A times M. Hence, by using divisibility, A over BC is proven.
For question number 5, let A, B, C, and X be integers with A and B are not both 0 and X not equal to 0. Prove that if GCD AB equal to 1 and X divide A, X divide BC, then X divide C. So, for the proof, let X divide A and X divide BC. Then, by using definition of divisibilities, we have X divide A, that is A equal to XK, K elements of integers. X divide BC, that is BC equal to XL, L is elements of integers. Then, A times BC equal to XK times XL. ABC equal to X square KL. C equal to X square KL over AB. Let M equal to XKL over AB. M is the element of integers. C equals to XM. Hence, by using definition of divisibility, X divides C. So, it is proven.
Next, we continue with number 6. By using mathematical induction, prove that 9 to the power of n minus 2 to the power of n is divisible by 7 for all positive integer n. So, we start with the first step, base case, to show n equal to 1 is true. So, we need to replace the power of n to 1. So, 9 to the power of n minus 2 to the power of n equal to 9 to the power of 1 minus 2 to the power of 1. So, we get 9 minus 2 is equal to 7. Let's go to the second step, inductive hypothesis. Assume n equal to k is true for some k is the element of n. So, for this step, we need to replace n to k. 9 to the power of n minus 2 to the power of n become 9 to the power of k minus 2 to the power of k. So, we need to write 9 to the power of k minus 2 to the power of k in equation expressing that it is divisible by 7. So 9 to the power of k minus 2 to the power of k is equal to 7x. For some positive integer x, solve for 9 to the power of k equal to 7x plus 2 to the power of k. Step for this equation is inductive step. Show n equal to k is true, then n is also true. 9 to the power of k plus 1 minus 2 to the power of k plus 1 is equal to 9 to the power of k times 9 minus 2 to the power of k times 2 is equal to 9 to the power of k times 9 minus 2 to the power of k times 2. So we get 7x plus 2 to the power of k times 9 minus 2 to the power of k times 2. So we get 9 times 7x plus 9 times 2 to the power of k minus 2 times 2 to the power of k. We get 7 times 9x plus 2 to the power of k. So the answer for 9 to the power of k plus 1 minus 2 to the power of k plus 1 equal to 7y. Since y is an integer, thus 9 to the power of k plus 1 minus 2 to the power of k plus 1 is divisible by 7. So, by principle of the mathematical induction, the statement is true for all positive integers.
From Theorem 7, we know ax plus by equals c has solution. So we can define from the equation value of a, b and c. First step, using Euclidean algorithm, we can define GCD of 13 and 11. So after that, we can get the GCD. The next step is you must know the value of GCD divided by C or D divided by C. From definition divisibility, 1 divided by 3, 6, 9. So you must define the value of M. M always be positive integer. For the step 3, you must define the X initial and Y initial. This is particular solution. From the step 1, E equal PQ plus R, you must take the equation 1 and then you just single the number of 1 and then you must replace the number of 2 with the 18 minus 11 times with 1. After that, after you get the answer and then you must multiply with the value of M. The value of M is 369. So you just multiply 369 with 6 and 369 multiply with 5 and then you get the answer and you can out the value of X initial and Y initial from the answer. Step number 4, you must define the value of X and Y using the formula X equal X naught plus B over T times with T and Y equal Y naught minus A over T multiply with T. And the value of A and B you can define from the question. After that, you put the value into the formula. So you can get the answer in pronunciation of T. X and Y is greater than 0. So you must use this formula and then you can get the value of T. So first, for X, you can get the answer T greater than negative 170.31. So you just use the same calculation to get the answer
Of y.
next. The conclusion from this solution, negative 117.31 is smaller than t, and the value of t smaller than negative 176.72. So we can conclude the value of t is negative 117, negative 169, and negative 168. So you must substitute the value of t in equation. The value of x and y after you substitute the value of t. Okay, so that's all from me. So that's all for the last step. So we can conclude the solution. The solution of x, y are 4 and 25, 17 and 14, and the last is 20 and 3. So that's all for today. Thank you.